Hello everyone, welcome back to my channel. Hope you all are doing great and good to see you all here in today's class. So before we move forward towards today's topic, hit the subscribe button so that you can get notified for the upcoming videos. Today we are going to learn an important topic from class 9 mathematics, chapter lines and angles. So in this video we will clearly understand some important theorems with the help of diagrams so that it will be easy for you to solve exercise problems and prepare well for your exams. And understanding these theorems, it is very important because they are the foundation for solving problems, and it will also be useful for you in your upcoming lessons. So let us see the very first theorem here. As you can see that the first theorem is alternate interior angles are equal. Okay, so first we have that alternate interior angles are equal. Okay, so let us move forward. So first we'll take diagram. So here it is given, as you can look here, a statement is given that let transversal PS meet line AB and CD at Q and R respectively. Assume AB is parallel to CD. Okay, so what it is given? It is given that we have two lines. Okay, two parallel lines. One line is named as AB, the second line it is named as CD. Okay, so we have two lines which are parallel to each other. One line is named as AB and second line it is named as CD. Okay, so to this parallel line, a transversal, okay, a transversal PS cut through these parallel lines. Okay, through this parallel line a transversal line is cutting. So let this transversal be P and S, and this transversal is cutting at point Q and at point R. Okay, as you can see, this is a diagram of this given statement. It is given that we have two parallel lines. So one is named as AB and other we named it as CD, and a transversal PS is passing through this two parallel lines, and we have 2 points Q and R. Okay, first let us write what is given. It is given that, okay, it is given that AB is parallel to CD, right? It is given that AB is parallel to CD and PS is transversal. Okay, what is transversal? It is given that PS is transversal. Now we need to prove angle RQB is equals to angle QRC and angle AQR is equals to angle QRD. So we have a statement that alternate interior angles are equal. Okay, we have a statement that if transversal intersect two parallel lines, then each pair, so this is one pair and this is one pair, so each pair of alternate interior angles are equal. So we are required to prove that angle RQB is equals to angle QRC. This is your first pair, and the second pair angle AQR is equals to angle QRD. Okay, so let us move to the solution. So the proof we need to prove. So since first we'll write down from the diagram, since AB is parallel to CD and we have a line, transversal line, which is PS. Okay, a transversal line PS is given and AB is parallel to CD. Now from this we'll get that PQA is equals to QRC. Okay, here we'll get two angles and here we'll get two angles. So PQA is equals to QRC. This is from corresponding angles axiom theorem. Okay, this is from corresponding angles axiom theorem. and we'll take this as equation 1. And you need to remember one thing, that when two lines are parallel and are cut by a transversal, so as you can see here, we have two parallel lines and they are cut by a transversal. We have a few conditions, or we can say few reasons, like the very first is corresponding angles are always equal. Okay, so whenever you have two parallel lines and a transversal is cut by these parallel lines, the first statement is corresponding angles are equal, and the second statement is vertically opposite angles are always equal. Okay, you need to remember two statements whenever we get two parallel lines cut by a transversal line. So the first statement is corresponding angles are equal, and the second statement is vertically opposite angles are equal. Okay, so here first we got it as PQA is equals to angle QRC. Now I have mentioned two statements, right? First is corresponding angles. We took it here. Next, we are required to see vertically opposite angles. Now, PQA is equals to angle RQB. As you can see here in this diagram, so this is the diagram. In this angle PQA, this is your one angle, and angle RQB, this will be your other angle. So these angles are vertically opposite to each other. So vertically 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 opposite angles at point Q. Take this as equation 2. Okay, now from 1 and 2 we have two equations, right? Equation 1 and equation 2. So from equation 1 and 2 you will get angle QRC is equals to angle RQB. Okay, so we proved the first pair. It is angle RQB is equals to angle QRC. So they are equal, and this is the first pair of your interior angle. As you can see, angle RQB, here you will get one angle, and angle QRC, here you will get one angle. So this is your one angle. So this is the first pair. We proved that angle QRC is equals to angle RQB. Similarly, in the same way, we need to prove angle AQR is equals to angle QRD. Okay. Now, similarly, we will prove for second pair. Similarly, angle PQC is equals to angle QRD from corresponding angles axiom statement. Okay, what it is that corresponding angles are always equal. Okay, from corresponding angle statement we got angle PQR is angle PQC is equals to angle QRD, right? Next, we need to look for vertically opposite angles, right? So the second statement you'll get as angle PQC is equals to angle AQR. These are your vertically opposite angles. Okay, these are your vertically opposite angles at your point Q. Now let this be your equation 3 and let this be your equation 4. Now from your equation 3 and your equation 4 you will get angle QRD is equals to angle AQR. Okay, here we prove the second pair, that is angle QRD is equals to angle AQR are also equal. Okay, hence we get that each pair of alternate interior angles are equal. Okay, we proved that alternate interior angles are equal, that is each pair of alternate interior angles are equal. Okay, this is the theorem we follow to prove that each pair, this is your first pair, right, and this is your second pair, right? So each pair of your alternate angles are equal. This was your first theorem. Next, this is also one more important theorem. So here the statement or the theorem statement, it is given that interior angles on the same side of the transversal are supplementary. So what is supplementary? Supplementary is 180 degrees angle, right? So we need to prove that interior angles on the same side of the transversal are supplementary. Okay, so the first statement was each pair of alternate interior angles are equal. We proved it. The second statement here is interior angles on the same side of the transversal are supplementary. So from this statement, let us draw the diagram. Let transversal PS meets line AB and CD at point Q and R respectively, and we need to assume that AB is parallel to CD. Okay, so this is your first line, this is your second line. So these two lines are parallel to each other. Let this be your line AB and let this your line CD. So these two lines are parallel to each other, and a transversal PS is cut through these two parallel lines. Okay, so whenever a transversal is cut through the two parallel lines, we have statements that corresponding angles are equal and vertically opposite angles are equal. Okay, so let us move to the solution. We need to prove that interior angles on the same side of the transversal are supplementary. Okay, so first let us write, it is given that AB is parallel to CD and PS is a transversal. Okay, and we have PS is transversal. Okay, given that AB and CD are parallel lines and PS is a transversal. PS is a transversal line. Okay, so we need to prove that angle RQB plus angle QRD is equals to 180 degrees, and next pair is your angle AQR plus angle QRC is equals to 180 degrees. So this your line, transversal line PS will cut at point Q and at point R. Okay, now let us begin with our proof. So how you'll solve this? By a theorem. Now the first pair here, the first pair is, what is your first pair? It is angle RQB and it is your angle QRD. Okay, now see here, your angle RQB and angle BQA form a linear pair at point Q. As you can see here, there is a point Q, and at this point Q you have angle RQB and you have angle BQA. So you'll get an angle like this here, so which forms a linear pair at Q. Okay, if you are not familiar with linear pair of angles topic, you can check out my previous videos in which I have explained the topic linear pair of angles. Okay, so first we'll get that angle RQB is equals to angle BQA. Now from linear pair of angles theorem, the sum of angles is how much? Angle RQB plus angle BQA is equals to 180 degrees. Let us take this as your equation 1. Okay, from linear pair of angles statement or theorem, we get that sum of angles is equals to 180 degrees, right? And since we have that AB and CD are two parallel lines and PS is your transversal line, you will get angle BQA is equals to angle QRD from corresponding angles axiom. Okay, from your corresponding angles axiom theorem. So let this be your statement 2. Now from 1 and 2, look this, observe these two equations, look at these equations. This is your equation 1 and this is your equation 2. You got that angle BQA is angle QRD. Now substitute this second equation in your equation 1. Okay, substitute, you need to substitute equation 2 in equation 1. What you'll get? So The rewritten equation here will be angle RQB plus what is your angle BQA? It is angle QRD, which is equals to 180 degrees, right? So this is your first proof that each pair of alternate interior angle on the same side of the transversal is equals to 180 degrees, which is supplementary. Okay, here as you can see RQB, this is your first interior angle, and next angle QRD, this will be your first angle and this will be your second angle. So on this same side of transversal, so the angles on same side of transversal is supplementary. Okay, angle RQB plus angle QRD is equals to 180 degrees. Next we prove this first pair. Next we will prove this second pair, which is angle AQR plus angle QRC. We'll follow this similar way like we followed for pair 1. So we'll write your pair 2. So what is your pair 2? It is angle AQR and angle QRC. Okay, now from linear pair of angles, at first here we took at point Q, now we will take at point R. So from linear pair of angles at point R, from linear pair of angles, from linear pair of angles at which point? At point R, you will get angle QRD plus angle QRC is equals to 180 degrees. Let this be your equation 3, and next you'll get angle AQR is equals to angle QRD. Okay, so from the theorem which we proved previously that alternate interior angles are equal, so from alternate interior angles theorem you will get angle AQR is equals to angle QRD. Okay, this pair we proved in alternate interior angle theorem. Okay, so let this be your equation 4. Now substitute this in your third statement. So what you will get? You will get angle AQR plus angle QRC is equals to 180 degrees. Okay, so this is your second pair and this was your first pair, right? So both pairs of interior angles are supplementary. We proved that both pairs of interior angles are supplementary. This was your first pair, sorry, this is a statement, and this was your first proof. We need to, this was your first pair that we are required to prove. So the first pair is supplementary and similarly second pair is also supplementary, hence we prove that both pair of interior angles are supplementary. Okay, so these theorems are very important. If you understand the theorems and if you remember the concept of these theorems while solving the problems, it will be very easy for you to solve the exercise problems easily. Okay, so the first theorem statement was alternate interior angles are equal, like each pair of alternate interior angles are equal, and the second theorem statement was interior angles on same side of transversal are supplementary. You can use these statements while solving your exercise problems. Okay, next we'll see an other important theorem, which is pair of alternate interior angles are equals and the lines will be parallel. Okay, if a pair of alternate angles, if a pair of alternate interior angles are equals, then the lines are parallel. Okay, similarly we have a statement here that let transversal PS meets line AB and CD. Let us take diagram. This is your line AB and this is your line CD. These both lines are parallel to each other and a transversal PS with points Q and R cut through these two parallel lines. Okay, now we are required to prove that if a pair of alternate interior angles are equal, then the lines are parallel. Okay, so first let us move with the solution. First it is given that What it is given? It is given that if a pair of alternate interior angles are equal. So first we will write a pair of alternate interior angle. Here as you can see, RQB, this is your first interior angle. Next, angle QRC, angle QRC, QRC, this is your other interior angle. So this pair of angles, if this pair of alternate interior angles are equal, so the lines are parallel. That is a statement we need to prove. First we have written that given RQB is equals to angle QRC. Okay, here it is given that pair of alternate interior angles are equal. Next, we need to prove that, what we need to prove, the lines are parallel. So what are the lines here? First line is your AB and second line is your CD. This is your line AB and this is your line CD. We are required to prove that both these lines are parallel to each other. Okay, so let us move to our proof. First, as you can see that at point Q, you have that angle RQB is equals to angle PQA, which are vertically opposite angles. Okay, these are vertically opposite angles. This will be your equation 1. Now as you can see that this is your equation 1 and it is given that angle RQB is equals to angle QRC. Now let this be your equation 2. Now from your equation 1 and 2, what you will get? You will get that angle PQA is equals to angle QRC. Okay, we got angle PQA is equals to angle QRC. Now as you can see here, this is your angle PQA and this is your angle QRC. Both these angles form pair of corresponding angles. So PQA and QRC, okay, both this pair, they form the corresponding angles, right? They form corresponding angles. Okay, they form corresponding angles. Hence, if these corresponding angles are equal, then two lines are parallel to each other. Okay, hence as we can see that these corresponding angles, the corresponding angles are equal, lines are parallel to each other. Okay, lines are parallel to each other. So these are the very important three theorems from your chapter lines and angles. If you remember these theorem statements, like when you solve your exercise problems, it will be very helpful for you to solve your problems very easily. Okay, so let me give a quick recap for you. The first theorem we discussed that pair of alternate interior angles are equal, and this second theorem we proved that interior angles on same side of transversal are supplementary, and the third theorem that we proved is a pair of alternate, if we have a pair of alternate interior angles which are equal, then the lines are parallel. Okay, so these are the very important three theorems. So that's all for today's class. We discussed three important theorems. I hope you understood the concepts clearly, and if you understood the topics very clearly, don't forget to subscribe, share and like the channel, and this will be very helpful for you to solve your problems. So subscribe to the channel for more upcoming lessons which I upload. Thank you for watching.